Hello, everybody. I hope you're here to play with these scanners, because that's what this is about for the next hour. My name is Mitchel Stangl, and I am the principal at Stangl Associates. I have two of my employees, Caton Capella, Chris Bassett, and two Trimble team members, Dave Burczyk and Gustav Choto. I said it right. And each of us will go with a scanner with 5 or 6 people. We'll walk around and touch the scanners and use it. And we'll try to talk to you guys about the experience of using them also when we're outside. My company, we're engineers. We do process design. I've been using SketchUp since 2001. We started using layout for all our drawings in about 2008. And I would say we're pretty dedicated users. And all of our output is in it. I get people asking me about precision and all those silly questions, and I hope everybody here understands that SketchUp is as precise as you want to make it. And we've had great luck with it. I find that hiring young engineers, that it doesn't get in their way and they can start doing work pretty quickly. So we saw scanning technology or experienced it probably 6, 7 years ago and made a commitment to buy scanners. We have 2 of them now, 3 years ago. And what it's stopped, or what it's helped eliminate, is going out in the field and being dirty for a week and a half, getting not enough measurements. So we typically now go scan the entire facility in a day to 3 days. And then we have accuracy down to a millimeter of everything that the scanner could see as we walk around and scan. And do we use all that data on any project? Probably not, but we go back to that data years later still and use that data. So it's really fundamentally changed how we do work. It's improved our accuracy. We're almost always doing brownfield work where we're going in and touching existing structures. It's helped us. We don't hire surveyors anymore. We just go scan the outside. Not that surveyors are bad or anything, but and I think that's the main thing. I would, anybody who, if you do a lot of field work, I would encourage you to get one. The discount I'll get from this show will also help me. But I haven't regretted it. It's a large expense, and the training really is on the next session we're going to do after this is really on the software side. And what we hope today is take a little bit of the mystique out of the scanner itself. So I'm going to stop now and let Dave talk, and Dave's going to talk to you a little bit about scanners in general, and then we're going to try to divide up into groups and go outside or out in the hallway.
All right, thanks, Mitch. So my name's David Burczyk. I'm the segment manager for our field technology group at Trimble. So I'm part of the Trimble Buildings group, and I'm focused around the development of our hardware solutions that are used in both design and construction. So that focuses on the 3D laser scanners, robotic total stations, and also mixed reality solutions, and how we apply that to the construction and design process. So what we wanted to do this morning is, in this first session, we have the 2 sessions. The first one is just to get hands-on with the scanners. So we're going to just go quickly through some slides here, give you a little bit of background information on the scanners that you're going to be working with. And then we're going to go out into the hallway and we're going to just do some hands-on. We're going to break everybody up into smaller groups. We have 5 scanners, and we'll break up into smaller groups, and then each of us will go with each scanner, and we'll walk you through the basics of the scanner. And the intent is just to get you some exposure to the technology and see what the process is just to start collecting scans. But the reason why 3D scanning has become such an integral part of projects today is that there's this industry demand for very accurate information being added to the models that are being used during the design and construction process. And the need to document these as-is conditions is what the 3D laser scanners help to provide. The data that's collected and the models produced from that information are being used to do things like pre-construction planning, going and tracking the progression of construction, and then even creating project deliverables. So a lot of projects are starting to have owners requiring that scanning be provided as a deliverable at the end of the project, because just like Mitch said, once you've scanned that information, you have very accurate measurement data that can be referenced years after the fact of the project being completed. So a lot of those larger projects are being required to now have deliverables at the end where scan data is being provided. And then a new area where scanning is being used is around construction verification, where as you're capturing scans on the project, they're taking that scan data and they're comparing it back to the 3D models. And you start to see what's been installed, what hasn't been installed, and you start to track kind of the sequence of construction based off of the scans. But what we're going to look at during the workshop, this first workshop, is just the TX series scanners that Trimble provides for scanning. So these are the scanners that are being used in design and construction. We have contractors that purchase these scanners. They go out and scan. We have some architects and engineers that have done the same, like Stangl Associates. And there's also services groups out there that will provide scanning as a service, to where they will capture the conditions for you and provide the scan data as a deliverable. And so the scanners that we're going to be working with this morning are the TX series from Trimble. And what's unique about these scanners themselves is that they provide high-speed measurements and high-speed scanning. So if you start to look at scanning, or if you have some familiarity around scanners that are out there, a lot of different scanners have different settings on them that reduce the speed and the time to capture data. And what's unique with the solutions that Trimble provides is that it's doing a high-speed scan. So it's always scanning at a high rate of speed. And so what you see up here on the right-hand side of the screen is what your average scan time is for the different levels that you can set within the scanner. And when we break up into groups, we'll go a little bit deeper into what that means with the different levels. But essentially what you're doing is you're establishing how dense of a point cloud you're creating with the laser scan. But the way the laser scanner works, you go out onto a job site, you set it up in multiple locations. So it's a line-of-sight device. So it's only going to capture what you see in a particular location for where you're setting up. So as you start to scan, you want to make sure that you look at what you're capturing, so that you can ensure that the data collected provides a comprehensive and a complete point cloud that represents the area that you want to capture. So that's really what you're looking at as you start to go out and scan, and then determining which level of a scan you're going to acquire. So we'll talk about that more when we go into the groups. But then with this type of high-speed scanning that the Trimble Solutions provides, it gives you a much more faster and effective way of being out on the job site to collect your information. So you have one speed, always a high-speed scan. You can get in and out very quickly on the job site. Like Mitch was mentioning, when his team goes out to a job site, they're spending from a day to 3 days to capture an entire project area. So you can go out and very rapidly collect that scanning information. And then the last slide I wanted to show before we break up into the groups is just to understand when you start hearing people talking about scan quality. The scanners that Trimble provides very high quality scan information. So on the left-hand side of the screen, what you're seeing is it's a cross-section through a 3D laser scan showing the quality of the scan. So this was a room that was scanned where there was some ductwork and some structural steel. And you can see what the scanner provided from the TX series, where it's very clean data. And what we mean by clean is the points are very tight, they're very compressed, and you get a very clear picture of what you've scanned. On the right-hand side is what you see from some of the competitors out there as well. And what you're seeing is in that same location, so we had scanners where we set up in one spot, scanned the area, took the other scanners and scanned the same area and did just a cross-section through the scanned data. We didn't do any altering to the data itself. But what you'll see is on the right-hand side, that's what some scanners will do on different surfaces. So this was some duct work, so it was reflective surface, and you start to see what's called noise, where the laser starts to bounce off those reflective surfaces, and you get a lot of this noise and distraction. And that's information that then starts to affect the way you're going to be modeling off of that information to create 3D models. So what's unique with the solutions that you'll be playing with this morning is that it provides this very clean, very concise data that's very accurate. And so it's a very unique situation in terms of the type of solutions that you have out there. So what we're going to do now is we're going to break up into smaller groups. Like I said, we have 5 scanners. We're going to go out in the hallway, and each of the team members with the scanners are going to just walk you through how to collect the scans. And then we'll start to go through and capture scans, have you actually get your hands on and play with it. And then After we do that for about 20 minutes or so, we're going to come back in here, and the team from Stangl Associates is going to show you what you basically just captured out in the hallway so you can get a feel for what the scan data looks like. Okay?
And I forgot to do one thing. How many people are architects in this group? How many people in construction, engineering, interior design? Go by yourself. Landscape design? Okay. Yeah, feel free to talk to us when you get a small group about what you're interested in, why you're interested in scanning, and talking about.
Okay. All right, well, let's head out to the hallway, and like I said, we're going to break out into smaller groups. Just pick a scanner. We're going to get them out to the hallway, set them up. Pick a scanner to stand by, and then we'll take it from there.
Well, welcome back. My name's Chris. I work with Mitchell, and I'm guessing you all had a chance to go out and try some of the scanners out in the hallway. Last night, we took the same scans and pulled them in so we can show you what the data looks like. Hopefully it can give you a preview of what it is you're collecting. We're using Trimble scanners, so using Trimble software to pull them in together. It'll be Realworks. And might as well just start by opening that up and show you getting the scans in and getting them registered. What's that? Mic's a little low? All right. Now we got more folks coming back. Caton, is the other group going to be in soon? Hey folks, welcome back. So I want to show you what the data you just collected looks like, so you have a feel for the data, the different settings. Before we fully open up, I want to touch briefly on how to access those scans, what's involved in getting them onto the computer, getting them into something usable and viewable. I'm not going to go too deep into it, but just show you briefly. When you're out operating the scanners, did you all see the flash drive inside? Put it in. Did you all make a project? Project name? Okay, so the one I did with the group was just called Basecamp. So we'll take that flash drive, put it right into the computer. If you're using a Mac, probably some USB-C dongle. But you bring it up and you'll see it right on the top drive of the flash. Drag that into the computer, onto your C drive, somewhere that you like. And you'll see that makes a Realworks file, and we open that up directly. And there's not much more to get it onto the computer than that. So, once it's opened up in Realworks, you'll see all the scans come in. They're not going to be together yet. They're all going to be separate. And they're going to look something like this. Big spherical point cloud, all the data you took. We took one right outside the door in the middle of the hallway, and you can see that black circle where the scanner was. You can see how all the data just fans out. Everywhere that's solid, that's a point you took. You can measure off that. You can view it.
That's unregistered?
This is an unregistered scan.
Wow, that's amazing.
So just to give you a sense, this is shown in perspective projection. This was done on the first setting, 0.075 feet at 100 feet. And so you get a sense of resolution. We can come in. Well, that's what the doorknobs look like at 20 or so feet. For us, we're often concerned with bolt holes, bolt patterns, how machines made together. Might not be close enough. We'd want to go up closer to that. But if we're just modeling for placement, this is more than suitable. It's up to you what you're trying to do with it. So we have the individual scans, and need to get them together. It's a process called registration. It's the other half of getting into usable data. Computer will do that automatically. As you notice, we did not use targets. Computer will stitch that together. function called plane-based registration. Looks at common faces, uses that. I'm not going to do that now, it takes a while. Show you the results though.
Okay, I just want everybody to notice what you're looking at when you look at the scan data is the backside of the surface we scan.
Yeah.
So we're not seeing the second wall, we're seeing the reflection. So,
And here's the hallway we have. I took 4 scans. A question I got was, how many scans do we need to take? And the answer was, what faces do we want to capture? So if we were concerned about seeing the inside, say, of all of the doors, like this one would need to scan in front of every door so you can see the insides. If you're not concerned with that and you know that having one door is good enough, you just need to know where the placement is, you won't need to do that. Less will be fine. Not taking them in the middle of the doors, you'll see blank spots start to come up, like say right here. The scanner couldn't see there, so it's not going to take anything. It's a line of sight device.
So it has a tolerance of distance? Does it have like a tolerance of distance? Is the laser
30 meters.
So you recalibrate that?
Oh, like,
Yeah, because the door's open, it would scan all the way in there what's happening.
He did, but that box around there clips the data.
Yeah.
So you would see the back of the room.
so we did pick things up.
Yeah, you did pick.
So,
But it's all in line of sight, so how much the door's open.
so in the case of that door we're just looking at, it did peer into the other room. And you can see the trails starting to come in here. Mm-hmm. Yeah.
So where was your camera when you scanned this? Inside the building somewhere?
Yes, this was the hallway right outside.
But you look at the roof also?
No, that's the ceiling. We're looking at the top end of it. So you're not actually seeing the ceiling. You're seeing the data from the
Oh, the
top.
bottom, oh,
That's the
okay.
floor right there.
Yeah, that's the ceiling. So,
Reflected ceiling plan with the roof.
yeah. So we're seeing this, ma'am. And you're just seeing the back side of that data.
Sorry, can you just take the roof off, and then you can show her where the circles are, where the scanner was in those locations?
Exactly.
Chris, was this a color scan?
This was a color scan.
The advantage of doing black and white is just faster.
How long did it take this to
How long did the stitching for this to take together? We took 7, 8 scans yesterday, a couple out in the courtyard too. Took about 30 minutes to register. No input from us, we just let it go. Came in 2 or 3 different groups, mainly between the transitions between inside and outside. Took a couple more minutes of manual manipulation and then we had something. Bigger scans, 100, 200, using the automatic registration by planes. Hit the go button, come back a day later. If it's 300, 400, 2 or 3. But again, we're not actually manually doing anything. We're just letting the computer churn along. So all it's doing is tying up a machine at the office.
The machine must make a difference.
The machine makes a big difference.
Does
processing? Or
Yes.
does?
Yes.
So if you got,
It's the only program we've ever seen that really is multi-processors. And we have a 12 process machine, and it'll take all 12 processors
yeah,
and sit there for a day, 2 days, 3 days, and then all of a sudden, it'll go on all 12 of them down.
wow.
It's a little bizarre.
And this won't process on a GPU?
No. It doesn't care what it looks like.
So I gather it likes the Xeon architecture, 12 processor.
The machine we're using uses Xeon.
Yeah,
Yes.
because I did do with Autodesk stuff. Not seen like on
Okay. Good to know.
Xeon. Anecdotal experience.
So will this go to polygons when you go into SketchUp, or will it stay in points?
This fellow here, Caton, will be talking about that in the next presentation, but
All you have now
in SketchUp, you'll see the point cloud. You can take a few points to make a construction point off of, but unless you do that, it's just a cloud. You can't snap to it. You won't have any of that, and it's very much like 3D tracing. If you've worked with modeling for PDFs in 2D, similar to that.
Just quickly, so you've registered 100 scans and you forgot one, can you just bring one into that, or you have to register the whole thing back again?
No.
No, you can bring one in.
Just add one?
Yeah.
Mm-hmm.
As long as they didn't tear the building down, you're fine.
Yep.
So if you're working in a facility that can't shut down and you develop a lot of noise, just like we saw in the hallway with people standing in there, how hard is it to scrub that out if you want to try to clean up the rendering?
Not too hard. Depends what the noise is. So I'm assuming you mean people
Right.
walking through. You
Maybe
could.
it could be equipment or something, like a routine process that was picked up in a facility.
Scrumming it out's not bad. If I'm modeling, I often don't bother. One thing I'd be more concerned about is if that person or the machine was blocking something important. So say if you have a big bucket loader, right in front of the scanner 3 feet away, that's going to take a large swath of the scan out. Get a great shot of the bucket loader, but all the stuff behind it's going to be blank. So less so than the noise, walking around, taking another scan on a different angle of the machine to get what you need. It's a primary concern. Sorry. Yeah.
You have 5 minutes.
5 minutes. So what did the scan? Yes.
I have a question. So you don't have a day or 2 or 3 to do registry. Is there a way to speed that up, like the manual registries? Would you need to add some targets or to have some reference points?
The manual is often not faster. If anything, you can break your total scan up into a few smaller groups, have them register together automatically, and then later on stitch those together if you don't want the machine down for like 3 or 4 days. But the targets, we have a big set we'd be happy to sell you. We don't use them.
Most stuff you do, like in the building, architecturally, you're not going to do 100 scans. And you can do this whole wing of the building with maybe 15 scans. And that's not, like it took them 7 minutes to register that last night. So it's
30.
not that big a deal. If you're doing something that's 100 scans, it's really complex, it just takes a long time to go through, because it's got to find, and if you're in a building with square edges, it goes way quicker.
Yeah.
Do you ever shoot some scans and find you didn't get enough overlap in the software that's...
Yeah, I mean, when he did that, because they did a view last night, and you have to manually, you can pick points, and if you know what you're looking at,
Yeah.
if you give it to a technician who doesn't know what they did, they may not be able to find 3 points. And we always register our own stuff. Of course, I'm the owner, so I don't always do my own, but if it bombs, I do, because I'm the one who saw it. You want to show them the Scan Explorer? Or
Yeah.
you got other stuff you want to show them?
Got a few things while we have some time. Just different resolutions, because I heard a lot of question about this. This was out in my neighborhood, and 160 feet away, my neighbor owns a Toyota Corolla. So this is what the preview scan looks like. You know, neighbor's house is a little fuzzy. Neighbor's house on the left-hand side of the screen is about 70 feet away. Beyond that, can't see much. That's the level 1 in the same location. Everything starts to tighten up, start faintly seeing my neighbor's house far away. That's the level 2. House really starts to show up. The neighbor's house on the left is really tight. You can see the siding. You know, the up close is very clear. And this is the long range, level 3. If I was to zoom in, I can see the Toyota symbol on the back of the trunk. So, something to keep in mind if you're going about and choosing your settings. If you're taking a lot of scans of things around angles, you know, often you don't need to do the long range because you will collect the data and the density anyways.
And that last scan would take 20 minutes.
Depends on the settings. The one we have does not use color, and it's a TX8, so that's a 10-minute setting. Color is involved, and it's a TX6, it'll take longer. Any questions? You want to see Scan Explorer? Sure. You're able to see the scan from the view of the scanner and go through all the stations.
Is that what the triangles are?
Yes.
Have you guys experimented or used drone scanning at all and compared it to what you get with this equipment?
I have not. If you are familiar, I would like to speak with you afterwards.
A little bit, but I'm not the guy who does it, so I wouldn't get into much detail.
Okay. Now, would that be the use of a laser from the drone itself, or would that be more of like photo and LiDAR?
I believe that's why I'm not 100% sure. I think we work for a construction company when we have used drones. I believe with laser scanners mounted to them, but it could be LiDAR or some other technology. I'm not 100% sure.
But drones are using photographs. They're taking pictures and then comparing pictures and using those.
Or LiDAR.
But it's, in the end, it's not as good as what we can get with tripods.
We've more or less suspected the same thing. So.
Can you export this into other formats like VR, panoramas or something? I don't know why you want to, but I'm curious.
Well, it exports into the, it's like the step equivalent. You know, if you're used to models, it's called E57 or a points file. Export those. And you can take certain, small parts, just a small portion of the whole scan or the whole thing if you want to, export it if you want to. For VR, what would the export look like from the scan if we wanted to use your HoloLens with this?
So you can bring the points in. We actually had our Dimensions conference 2 years ago. I did have a proof of concept to bring points cloud into HoloLens. And you can do it. You sample back points. We did in that particular instance. I had to export out as an LAS file, which is very heavy in terms of file size. But I had to sample back the points to about it was probably about 8 million points or so. And I can get it into the HoloLens. I can show you a video on my computer later if you want to see it. But it's very chunky. So as you go through and you start to look at it, it's big chunks, it's steps. So it's not fluid. And so what I've seen is, it's better to go with more of like a VR application where you can have the horsepower of your computer to dive into the points that way, because then it becomes much more fluid, and it's much easier to fly through it and actually experience the point cloud itself.
Yeah.
So, but it can be done. But the limitations there is just the HoloLens itself, what it can handle. But that was it was an LAS file, so we should not much more done with that.
Yep. Yeah, we're done.
This is primer for the next session.
This is a primer for the next one. She'll be using this data to model in SketchUp.
See you back in here in 15 minutes. Yeah. Come back.